Okay, 6.7. We are reviewing now for our quiz assessment coming up on everything we've done so far in Unit 6 on solving quadratics. So a lot of stuff we covered in here, but it still ties over to what we did in Unit 5. So we first started out everything in this section about solving a quadratic equation. So taking those quadratic graphs, writing them equal to something and solving it. Solving an equation by taking the square root of both sides. Understand that when we take the square root of both sides, our answer will have a plus or minus. From there, we moved into the ability to factor and solve quadratic equations. So if you can factor the quadratic, that's sometimes quicker and easier than doing the square roots. We factor two different kinds. The ones that look like x squared plus bx plus c. There's a 1 in front of the quadratic term. Ax squared plus bx plus c. There's a number other than 1 in front of the quadratic term. So be able to do factor by grouping. We did that in the course of solving the quadratics. Solve by completing the square. Okay, that was the method we did after we did the factoring. And then the last method that works every time is the quadratic formula. You must know the quadratic formula. You must be able to use it and try not to make mistakes with it. Then we talked about the discriminant. The discriminant is that special part of the quadratic formula, b squared minus 4ac. And that tells us things about the solution. I honestly, if I'm taking this test, I would not overlook what the discriminant does. Know what the discriminant is, know what the values of it mean, know what it means graphically. Then to be able to solve quadratic formulas using any of these methods, square root, factoring, quadratic formula, and then the other method is completing the square, which is not listed here. So all of these methods for solving quadratic equations. So let's go ahead and look at a few examples then. Solve the following by factor by grouping. Remember, factor by grouping is just the greatest common factor. You apply it to every time. So the first two terms have in common, it looks like a 3x. So if I factor 3x out, I'm left with 2x plus 5. Copy down the next sign, which is a plus. Factor out a 2, and I'm left with 2x plus 5 equals 0. So this gives me 3x plus 2 times 2x plus 5 equals 0. Two factors multiplied to get 0. You set each of those equal to 0. If 3x plus 2 is equal to 0, 3x is equal to negative 2, or x is equal to negative 2/3. That's one solution. And then if 2x plus 5 is equal to 0, 2x equals negative 5, x equal negative 5 halves. That is the other solution. Solve these two by factoring. Okay, so the first one has a 1 in front of the x squared term. This will factor if I can think of two numbers that multiply to give me a negative 45 and add together to give me a negative 4. Okay, that's going to be a negative 9 and a positive 5. But if I don't know that, what are the factors of 45? It's 1 and 45, 3 and 15, 5 and 9. And then it starts to repeat itself after that. The only way I can get a negative 4 out of that is if I had a negative 9, positive 5. Those numbers multiply to negative 45, add to negative 4. So this can be written as x minus 9, x plus 5 equals 0. And set each of these equal to 0. X is equal to 9 or negative 5. Those are my two solutions to that quadratic. So what these are the x-intercepts. Okay, when you set a quadratic equal to 0, you're setting y equal to 0, solving for x. These are the x-intercepts of this equation. If we look at the next one, this will factor if I can find two numbers that multiply to give me whatever 15 times 2 is, which is 30. And these numbers need to add to give me 11. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6, and then I'll start to repeat after that. The only way to add those and get 11 is a 6 and a 5. So 6 and a 5. Because this number is not a 1 in front of that x squared term, I have to rewrite this equation in order to use factor by grouping. So plus 5x plus 6x plus 2 equals 0. And then I'm going to factor this by grouping. What do the first two terms have in common? It looks like a 5x, and I'm left with 3x plus 1, plus, if I factor a 2, 3x plus 1 equals 0. This tells me 5x plus 2 times 3x plus 1 equals 0. Set each of those equal to 0. X is negative 2 over 5 or negative 1 over 3. Those are your two solutions to that quadratic equation. Solve using the quadratic formula, okay? You got to know the quadratic formula. If you make mistakes on this, you can expect to get the whole problem wrong. Negative b plus or minus b squared minus 4ac. All of that is divided by 2a. Well, to use the quadratic formula, I want this thing set equal to 0. 5x squared plus 9x plus 7 equals 0. A is equal to 5. B is equal to 9. C is equal to 7. Okay, so b squared minus 4ac is going to be 9 squared minus 4 times 5 times 7. So this is going to be 81 minus, what is that going to be, 140. And so 81 minus 140 is going to be negative 59. So I know the discriminant is negative. I expect complex solutions here. So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac is negative 59. All of that divided by 2a. It is 2a, sorry, 2a, which is 2 times 5. So this is x equal negative 9 plus or minus the square root of negative 59. That's going to be the square root of 59 times I, all of this over 10, okay? And that does not reduce any further than that. So you can leave your answer like this. The other option is you write it x equal negative 9/10 plus or minus I over 10 times the square root of 59. Either of these should be sufficient answers for this. Solve the next one using the quadratic formula. In this case, A is equal to 2, B is equal to negative 5, C is negative 7. So B squared minus 4AC is equal to negative 5 squared minus 4 times 2 times negative 7. So this is 25 plus 56, which is 81. Okay, so this tells me x equal negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And so this tells me x equal 5 plus or minus 9. All of that is over 4. So this one you can take all the way out. So this tells me that what are my solutions going to be? It's going to be x equal, so 9 plus 5 is going to be 14 over 4, or negative 4 over 4. So this is going to be 7 halves or negative 1. Continuing on, solve by taking the square root of both sides. To take the square root of both sides, I want to isolate what is being squared. It is the x that is being squared. So I'm going to write this as 3x squared equal negative 28 plus 7. So 3x squared is equal to, if I subtract 7, that's negative 21. Divide both sides by 3, and I get x squared is negative 7. Now I'm ready to take the square root of both sides. So I'm going to get the square root of x squared equal plus or minus the square root of negative 7. That tells me that x equal square root of negative 7, so it's plus or minus I square root of 7. That is the solution there. In the next one, what is being squared is the x minus 2. It is already isolated. Take the square root of both sides here, you get x minus 2 equal plus or minus the square root of 16. X minus 2 equal plus or minus 4. X equal 2 plus or minus 4. Therefore, x is equal to 6 or negative 2. In the next one, you've got questions at all or questions about the discriminant, okay? So let's just take a look and see what we can figure out. Remember, the discriminant is b squared minus 4ac. So what is the discriminant here? The discriminant is going to be 20 squared minus 4 times 4 times 25. And so this is going to be 400 minus 400. The discriminant is 0. If the discriminant is 0, okay, keep in mind what your quadratic formula is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So the discriminant is this piece right here, okay? If that is 0, then I'm not going to have a plus or minus in my answer. I'm only going to get one solution. I get one solution. It's going to be real, and it's going to be rational, okay? It's just going to be negative b over 2a, okay? So let's take a look at the next one. What is the discriminant in the next case? It's going to be b squared, so negative 2 squared minus 4 times 1 times negative 2. So this is 4 plus 8, which is 12, okay? So that tells me I'm going to be taking the square root of 12. So I'm going to get a plus or minus square root of 12 in my answer. I'm going to have two solutions, okay? Plus or minus square root of 12. That's a real number, but square root of 12, that's not a perfect square. That's going to be an irrational number. So I'm going to have two real rational solutions here. Let's look at the next case. B squared minus 4ac is going to be 2 squared minus 4 times 1 times negative 3. This is going to be 4 plus 12, which is 16. So my answer is going to have a plus or minus square root of 16. Square root of 16 is 4. 16 is a perfect square. So what I'm going to get here is I'm going to get two solutions. I've got a plus or minus, but it's plus or minus 4. So I'm not going to have a square root in my answer. I'm going to have a real number, and it's going to be rational when I get to the final answer. The next one here, and sort of an oversight here, this needs to be equals 0. The discriminant is going to be b squared, so that's 2 squared minus 4 times 1 times 5. That's going to be 4 minus 20, which is negative 16. So I'm going to need plus or minus square root of negative 16. Well, I'm going to get two answers, but they are going to be complex answers, okay? And that is it. So this is where you really need to know what happens with the discriminant, either having memorized it or better yet, just be able to reason through what the quadratic formula does, okay? Solve by any method, okay? If I look at this one is begging to be solved by taking the square root of both sides. Take the square root of both sides. X is plus or minus the square root of 17. X equal 4 plus or minus square root of 17. Looking at the next one, can it factor? If it factors, I'm looking for two numbers that multiply to negative 2 and add to 1. What numbers multiply to negative 2 and add to 1? It looks like a negative 1 and a positive 2. They multiply to negative 2, they add to positive 1. This can be factored as x minus 1, x plus 2 equals 0. Set each of those equal to 0. Your solution is 1 and negative 2. Looking at the next one, this will factor if I can find two numbers that multiply to 1 and add to 1. The only possibilities are 1 and 1. They multiply to 1, but they add to either 2, or I could get them to add to a -2. So this will not factor. I'm going to need the quadratic formula or complete by completing the square. Let's do it both ways. If I'm using quadratic formula, a is equal to 1, b is equal to 1, c is equal to 1. So x equal -b plus or minus the square root of b squared, which is 1 squared, minus 4ac, all of that over 2a. So x equal -1 plus or minus, that's a 1 minus 4, which is a -3, all of that over 2. So this is x equal -1 plus or minus I square root of 3 over 2. So those are your two solutions. You could write it as -1/2 plus or minus square root of 3 over 2i. Either of those would be good solutions for this particular one. How can I solve this using completing the square? So to complete the square, okay, I would have x squared plus x equal -1. So I need to add, what is in front of this x is a 1, so I would need to take half of that and square it. So plus 1/2 squared. If I add 1/2 squared to the left, I must also add 1/2 squared to the right. So this gives me x plus 1/2 squared equal, and this is -1 plus 1/4, which is -4/4 plus 1/4, which is -3/4. So I get x plus 1/2 squared equal -3/4. Taking the square root of both sides, I get x plus 1/2 equal plus or minus the square root of -3 over the square root of 4. This is the square root of 3i over 2. So, and my final answer here would be x equal -1/2 plus or minus square root of 3 over 2 times I. And that's the same answer I saw a moment ago. So either way to complete that one. Okay. Looking at the next problem, will this factor? Are there things that multiply? So I've got 6. So are there numbers that multiply to 18 and add to 11? Okay. It looks like what, 1 and 18, 2 and 9, and those look like the ones 2 and 9 will add to 11. So I can write this as 6x squared plus 2x plus 9x plus 3 equals 0. Factor by grouping. 2x, 3x plus 1 plus 3. 3x plus 1 equals 0. So 2x plus 3 times 3x plus 1 equals 0. This tells me that x is equal to -3/2 or -1/3. Now, if I didn't see that it was factorable, I could also use the quadratic formula here. So a is equal to 6, b is equal to 11, c is equal to 3. Okay, so this would be x equal -b plus or minus the square root of b squared minus 4ac, all of that over 2a. So this is x equal -11 plus or minus the square root of 121 minus, what is that, 18 times 4, which is 72. All of that over 12. So 121 minus 72, 49. So this is negative 11 plus or minus the square root of 49 over 12. That's negative 11 plus or minus 7 over 12. So this becomes, if I take the plus sign, it's negative 4 over 12. If I take the negative sign, or minus 18 over 12. Those can simplify. So the first number, if you take out a 4, that's negative 1/3. And the next ones you can factor out a 6, and so that's negative 3/2. And those are the same answers we got before. So either way to get to the answer on that guy. And then a couple of examples completing the square. So to complete the square here, you're going to have x squared plus 3x equal 1. So I need to add half of this number, so 3/2 squared plus 3/2 squared. What I get on the left, this is a perfect square. This is x plus 3/2, all of that squared, is equal to, this is 1 plus 9/4. You can think of this as 4/4 plus 9/4. So I get x plus 3/2 squared is equal to 13 over 4. Now I take the square root of both sides. X plus 3/2 equal plus or minus the square root of 13 over the square root of 4, which is 2. So my answer here is x equal negative 3/2 plus or minus the square root of 13 over 2. So those are my answers using completing the square. In the next one, when I do the completing the square, I've got 2x squared plus 4x equal 1. You have to factor what is in front of the x squared term. So this is 2x squared plus 2x equal 1. And now you add half of what is there in the x term. So half of that, so I'm going to be adding 1 squared, okay? What did I really do to the left? I'm adding 1 squared, but it's multiplied by 2. So I have added 2 to the left side of the equation. I must also add 2 to the right side of the equation. So this gives me 2 times x plus 1 squared equal 3. X plus 1 squared equal 3/2. So x plus 1 equal plus or minus the square root of 3/2. X equal negative 1 plus or minus the square root of 3/2. Okay. Now there are a couple things that I did not see on this review. Remember we talked about rationalizing the denominator. So do not overlook this. So if you see something like 2 over the square root of 11, how can you write that where there are no square roots in the denominator? Well, you can multiply it by the square root of 11 over the square root of 11, and you get 2 square root of 11 over 11 as your answer, okay? I've rewritten this where there are no square roots in the denominator. How would you handle something that was like 2 over 1 plus the square root of 5? Well, you would need to multiply this by 1 minus the square root of 5 over 1 minus the square root of 5. When you do that, you get 2 times 1 minus the square root of 5 over what I get in the denominator. When I FOIL that, 1 times 1, I get 1. I get plus the square root of 5 minus the square root of 5 minus the square root of 5 times the square root of 5. So this gives me 2 minus 2 square root of 5 over 1. These two terms cancel, and this is just minus 5. So this is 2 minus 2 square root of 5 over negative 4. So this gives me negative 2/4 plus 2/4 times the square root of 5. We can simplify that further. That's negative 1/2 plus 1/2 square root of 5. And sorry, this is not a plus or minus. This is simply a plus. Okay. Yeah, another way of thinking, this is what, negative 1/2 plus the square root of 5 over 2. Another way to write that. Okay. So that's rationalizing that that expression. Okay. And that should be the review for everything we've done in this particular section. Like I said, pay close attention to the methods of solving, but the definitions of discriminant and what it means graphically in terms of your solutions.